Hello grade 12s, welcome back to another video. So we will be doing question 3 of this question paper, the physical sciences, the March 2024 test for the KwaZulu-Natal Provincial Department. Hello guys, welcome back. Please don't forget to like, comment and subscribe to the channel. Without wasting any more of your time, let's get into this video. On the video before this one, I did this Newton's law questions, and on today's video we'll be doing this question 3 and this question 4 respectively. So this is momentum and impulse, question 4, and then we have vertical project line in question 3. So question 2 and question 3 for under vertical projectile. So it's very important that you know them. And I covered a lot to show you different types of forces in question 2, reminding you a bit of grade 11 work, because it's very important that you do. This is how your test will be structured, and then after this we have chemistry as question 5 and 6, and that will be dealt with again. Chemistry will be dealt with in the next video, so they are part of a playlist. So before this one we had question 2. Now let's start. A hot air balloon moves vertically upwards at a constant velocity of 72 kilometers per hour. When it is h meters above the ground, there is a hot air balloon up there, and then here is h meters above the ground, and then there we have the ground. A ball is dropped. So when the hot air balloon, it is h meters above the ground, a ball is dropped from the balloon. So whoever is in the hot air balloon drops a ball at height y there. The ball reaches its maximum height above the ground at z. Okay, so the hot air balloon is at h meters above the ground. A ball is dropped from the balloon. The balloon reaches its maximum height above the ground at z. Refer to the diagram below. So this at h, whoever is in the hot air balloon throws up the ball. The ball reaches its height of z and then comes back down. Assume that the dropping of the ball has no effect on the speed of the hot air balloon. Ignore air friction for the motion of the ball. Okay, so the ball and the speed of the hot air balloon does not affect the ball. Give a reason why the ball keeps moving upwards after it is dropped. So the reason why a ball will keep going higher even when it has been dropped is because of something called inertia. So this is a property of matter by which it continues in its existing state or rest or uniform motion in a straight line unless that state is changed by an external force. Okay, that is 3.1. Let's look at 3.2. So we'll say 3.2, and that is 3.2.1. And then let's do 3.2.2. Yeah, we will answer those. So for 3.2.1, this 3.2 says, what is the acceleration of the ball at point? Firstly, we need to check at point z. So z is there above h. that is the acceleration of the ball. So we can say it's 9.8 meters per second down, or we can say it's 0. So we'll just write 0 there. That's where it is, or you can still write it like this. You can, it's either you say 0 or you say 9.8 meters per second. It's just held by friction now, and then it has to the power of -2. Yeah, it's going downwards, and the direction, it will be going downwards there, so we'll also include the direction. Friction is the one taking care of it there. Okay, trying to put it down. Not friction, forces of gravity, yes. And then, which is 9.8, that is the forces of gravity. And then here we have, so it's what is holding the ball, -2, as you know. That's how we write it. And then what is the acceleration of the ball at point Z? It's still the same. It's 9.8 meters per second down watts, because this ball is coming downwards. Okay, so that is the answer there. It's just held by gravity. When you just take it up, there is gravity holding it, keeping it there. All right, let's look at 3.3. It says calculate the time it takes for the ball to reach its maximum time. So how much you have to calculate time. How much time? Calculate the time it takes for the ball to reach its maximum height. So when we're using time, I'm just going to the formula sheet. There you're going to use the motion. Okay, so in the formula sheet you're going to use motion formulas. So we have to see the one that has time. The first one in that block of motion, it has time, and then the second one also has time, and the third one has time. Now what you have to know is, what do you have? Okay, what do you have? How long will it take for this to reach a maximum, to reach its maximum height? So you need to have final velocity to use the first one, initial velocity, acceleration due to gravity, it's that A. So let's look for that. Let's look for that. All right, so here we have, let's do a space like that. All right, so the initial velocity, we are at, how calculate the time it takes for the ball to reach its, calculate the time it takes for the ball to reach its maximum height. Okay, so the ball is at the top there at 72 kilometers per hour. Can you see the ball right next to the hot air balloon at Y? So how long will it take to take its maximum height? So we are going to take this ball is going to end up at the ground. Okay, so its final velocity will be at 0 because the ball is dropped down. Okay, they dropped the balloon from the hot air balloon, so it starts at 72 kilometers per hour. We need to convert kilometers per hour to meters per second. Okay, so your velocity should be in meters per second. So we're going to say 72 kilometers per hour divided by 3.6, and that will equal 20 meters per second. That's what we're gonna do first, and then the second thing we're gonna do, we're gonna use this we have final velocity equals to initial velocity. We have initial velocity, and then it's gonna be plus acceleration due to gravity and change in time. We're looking for time. So for final velocity we have 0 because it's going to end up at the ground from 20. That is initial velocity where the ball is, plus 9.8 force due to gravity. Yeah, we'll be working with this a lot, and then we don't have the change in time. So 0 equals to, we're gonna take the 20. So we need to choose direction. So in this example, I will take upwards. When it's going upwards, it's positive. So when it's coming down, it's negative. So it's coming down. So we'll have a negative 9.8. So in your calculator, I'll say 20 plus 9.8, and that will give me 29.8 change in time. So that will be, oh sorry, this is they are multiplying. We can't add like this. Negative 9.8 multiplied by change in time, they are both multiplying. Okay, so the 20 will come this side. Yeah, I will have the 20 to come this side is equals to negative 9.8 change in time. Yeah, so this is what we will have, and then we will divide by negative 9.8, divide by negative 9.8 so that we cancel it, and then yeah, let's say 20 divided by 9.8. So that will mean that change in the time will be 0, not 0, 2.04 seconds. So that will be the time. So this is how you calculate. You convert your kilometers per hour to meters per second. Then we have final initial. So the ball is starting at 0, is starting at 20 meters per second, which is there at y, is being dropped from the hot air balloon, so it has to reach ground. So the final velocity is 0. When something has to end up at a still position, its final velocity is 0, but if it starts at rest, then its initial velocity is 0. Okay, so yep, if you choose upwards as positive, then the 20 will be negative and the 9.8 will be positive. So the 20 will be negative and the 9.8 will be positive because upwards is positive, so the ball is coming down. The force due to gravity, acceleration due to gravity, is taking the ball down. Okay, so that's why it is negative. So here we have to answer question 3.4. So in question 3.4, they say calculate the displacement between the hot air balloon and the ball when the ball is at its maximum height. So distance is displacement. Whenever you're asked to calculate distance, they're asking you to calculate displacement. So you need to find a formula where we have displacement. So firstly, let's try to calculate displacement. So we are going to take change in y and z are displacement. So just look for where you have displacement in your formula sheet. So we have calculate the distance between the hot air balloon and the ball when the ball is at its maximum height. So there is a displacement between the hot air balloon when it's at its maximum height. So we are going to do that. Initial velocity is 20. So we're still going to use we're going to first calculate the displacement of the ball before we calculate the one for the hot air balloon. So the initial velocity of the ball is 20, and then change in time, we just calculate it, is 2.04. So here we have the displacement of the ball. Okay, ball will be y, so that will be 40.80 meters, displacement in meters. Now we will also find the displacement of the hot air balloon. Now that we have look at this, now that we have of the ball, now let's do the displacement of the hot air balloon. I will still use another formula. Final velocity, change in time, we have the final velocity plus 1/2 change in time. So this is the formula that we're going to use. We'll say change in y. Let me do this. I'm trying to make this to be a bit bigger. So let's do this. Y equals to final velocity change in time plus 1.5 acceleration due to gravity and change in time squared. Now this is the formula. So the change in y equals to final velocity of the hot air balloon, because it started from ground and it goes up, it's also 20, and then we have 2.04, that is the time. change in time that we calculated, and then we have 0,5, and then this 9.8, and then we're still going to take the 2,04 squared. I don't have space there, and then the change in y here will be 20,4 meters. So we'll take the 40,80, and then we will minus the 20,4 meters, and then change in y, and then yeah, the final answer will be when the distance will be 20,39 meters. So here is the distance. So we have to calculate the distance between the hot air balloon and the ball when the ball is at its maximum height, as you can see in that drawing that you have shown the ball there. So this is the calculation. Let's check the memo. So this is the memo for that question if you chose up as negative. And then here is question 3. Question 4, sorry. Yeah, that is how you calculate the distance. So the last one is question 5. Question 5 says, sketch a velocity time graph in the answer book for the motion of the ball from the time it is dropped until it hits the ground. Clearly show the following on the ground: the initial velocity, the time it takes to reach the maximum height, the time it passes y on its way down. So that is what we just simply need to do. So I'm just gonna try to see if I can draw the graph. Yeah, it's not right. Let's do this here in the middle, and then here we have 20, and then here we have negative 20. Okay, so yeah, I will still show it to you in the memo, don't worry. So we'll come from here, and then this part will have 2,04. We'll have 2,04, which is the time, and then at this point, from there, they will have 4,08 time in seconds. And then, so guys, from this point, in fact, from here to here, going to this direction, we are starting at let's say let's sketch a velocity time graph in the answer book, for the motion of the ball. All right, yeah, so the ball starts at 20 and it goes down like that. It takes it 2,04 from the ground to up. From upwards maximum height to the ground, it takes 2,04, and then from this 2,04, let's see, So the 20 up here is the initial velocity. Yeah, I want to show you how to answer it correctly. We have the initial velocity as 20, the time it takes to reach its maximum height. We said that from ground, or from its maximum height to the ground, the time it takes is 2,04. So we calculated that it takes 2,04 to reach its maximum height, right? So the time it passes point Y on its way downwards, okay? So from point Y going downwards, it's still its maximum height. So it's going to take, we're gonna say 2,04 times 2. So that is where it's negative. We will say this one is it's negative, going into the negative direction. So below here, it's in the negative direction. This one, it's in the positive direction. Okay, and I hope you understand that. So with the memo, I chose upwards as positive. So that is how we are going to do it. So when it's going upwards, it's for this direction, it's going upwards. And then when it's going downwards, this is the position when it's negative. Okay, so here is when upwards it's negative. So that is how you have to draw it. Okay, let's look at this question 4 so that we can complete this video. A minibus taxi with an unknown number of passengers travel at 30 meters per second when it collides head-on with a car of mass 1100 kg traveling at 20 meters per second. As shown in the diagram below, during the collision, the vehicles stick together and travel at 20 meters per second immediately after the collision in the direction of the original motion of the taxi. So this is impulse. What do you call it? I will remember that topic. It's just that you see when something can just slip your mind just like that. Yeah, but I will link the topic in the description box down below. What is it? Impulse, pause and impulse, pause. Yeah, guys, I don't know what's happening, but I just forgot about it. So that is question 4. All right, so we are going to answer 4.1 together. So these two entities come together, they collide, and then after colliding, where I did this video, I dealt with the theory. It will make things very easy. After they collide, they stick together and travel in the same direction. Okay, so a bus and a taxi get into an accident. After getting into an accident, the bus is coming towards the taxi is coming towards the bus, and then they go in one direction. Maybe they will go in a direction in which the bus was hitting the taxi in because the bus is stronger. Let's just say that. So the average mass of a minibus on South African road is 1,500 kgs. The law states that the combined mass of all the passengers in a minibus and taxi itself should not exceed 3,500 kg. What is meant by the term isolated system in physics? So when a term is isolated, they mean that a system on which the net external force is 0. So that's what they mean about, or they talk about an isolated system. So here we are on 4 point. We're going to answer 4.2. So a system on which the net force is 0, that is an isolated system. So they said, what was the minibus taxi overload? Support your answer. So here it says the average mass of a minibus taxi on South African road is 1,500. Right? And the law states that the combined mass of all the passengers in a minibus taxi and the taxi itself should not exceed 3,500. So no, it wasn't, because the total mass is less. Yeah, so it's 5 marks. So we have to support it with calculations. We can't just say that. So remember this formula. I did this formula when I was doing this this topic for you, momentum and impulse. Yes, it's called momentum and impulse. So we are going to need initial momentum times initial velocity plus momentum 2 final velocity 2 equals to momentum 1 plus momentum 2 and then final velocity. Okay, let me show you how this formula looks on the formula sheet. I dealt with this, so you have to know it. They didn't even show it on the formula sheet, so meaning you have to know it by heart, but I've dealt with the theory, so it's not a problem. Yeah, we have initial momentum, initial momentum 1 plus initial velocity. So a minibus taxi with an unknown number of passengers travel at 30. A minibus taxi. So the minibus taxi will be, let's take it as 1. Okay, so it's momentum 1 and initial velocity is initial velocity. So taxi will be 1. So we don't have let's see, it's traveling at 30 meters per second when it collides head on with a car of mass 100 kg. So sorry, this is not momentum, it's mass. So we don't have mass of the taxi, but we only have its velocity, and then we have the mass of the mini taxi is 1. So the mini taxi is 1. It collides, a mini bus taxi with an unknown number plate travels at 30 meters. It collides head on with a car. Yeah, this is the mini taxi. You have velocity, we don't have its mass, and then the mass of the car is 1,100. Yeah, so we're going to have 1,100. That's the mass of the car, and then it's traveling at 20 meters per second. So the car is coming into, we'll take the direction of the car as positive, so it will be minus, and all that is equals to mass 1 plus mass 2. I'm just gonna write it here. So the mass of car 1 is m1, we are not given it, plus 1100, and then we gonna times during the collision they end up going at 10 meters per second. So after they stick together, they now travel at a final velocity of 10. So that's why we have it like that. Okay. Yeah, that is why we have it like that. So I'll show you guys on the memo, because I know, yeah, the space is small, so I'm trying to squeeze everything in there. And then when you add this everything in the left hand side, let's say you will have it's 1100 times the 20. So this side we will have 30m plus 22,000, and then that is equals to m plus, oh, this will be 10m plus the 1100 times 10, that will be 11,000. So we have 30m minus 10m equals to, all right, so let's do this. We have so we're gonna have m30 plus, it's not even plus, it's a negative 22, that is 1100 times the 20, okay, times the negative 20. This 20 here is negative, so we have the negative 20 here, and then is equals to this m times this 10, so that is 10m, and then plus this 1100 times 10, that is 11,000. That is 11,000. So here we have m30, and this one will come this side, that is minus the 10, and then we will have the 11,000 plus the 22,000. So we will have m20 is equals to 11,000 plus 22,000, that will be 33,000. Yeah, we'll have 33,000. Then we will divide by 20 to get m by itself, 20, then m will equals to 1,650 kg. So 1,650 kg is the m, the mass. 1,650 will be the mass of the mini bus. Okay, so it does not exceed. Yeah, you will say yes, it does not exceed. So we are going to answer 4.3. So for 4.3, calculate the distance that the minibus car system moves after the collision. Yeah. Oh, when I give you the answer, I was answering for them. Yeah, I only took the average mass. No, we had to calculate and find out. So we have calculated and find out. So for 4.3, calculate the distance that the minibus taxi car system moves after the collision. So during the collision, the vehicles stick together and travel at 10 meters per second immediately after the collision in the direction of the original motion of the taxi. So I will assume it's because the taxi is bigger. Yeah, so when you are asked to calculate the distance, you're asked to calculate displacement. So I'm going to use this formula. F final velocity squared. I'm going to use this one on the motion part of the formula sheet. That one that Vf squared equals to Vi squared plus 2a change in x. That's what I'm going to use for this question. Okay. Yeah, boo. So we're going to say equals to Vf squared plus 2a, not, but it's x. X is displacement. Displacement is your distance. So final velocity, they're going to end up at 0, and then after they stick together, they started traveling at 10 meters per second. So that is our initial velocity, and then plus the 2, and then let's see, I decided to use another formula that is more faster. Okay, so I'm firstly going to find time. Okay, so I will use this one. F net equals change in momentum over change in time. So the F net will equals to mass final velocity minus initial velocity over change in time. Yeah, this is what I will do. So let me just do this to create some space. Now here it's m into final velocity minus initial velocity over change in time, and then with that we are going to substitute. So the F net, we are given that the surface exerts a consistent frictional force of 2,500 rand. So it's not 500 newtons. No, that is not in rand. So we have 2,500 is equals to the mass of the minibus, which we calculated as 1,650, plus the mass of the small car, which is 1,100, and that will be over change in time. So what will happen is that we will cross multiply here. Why is it? So we are going to cross multiply. Hey, I'm struggling to have this on one page. Let's see if it will agree. So we'll cross multiply the 2000 the 2500 will multiply with the change in time, and then that will equals to, oh sorry, I didn't write the correct things here. So this is the 2500 we are given on the question paper. Then we will have the 2750, which will be the 1100 mess for the small taxi, and the 1060 for the bigger one. So that is going to give us 2750. So this 2760 is for the 1100 plus 1650. So those are the masses of these two cars. This one here, it has been given to us. All right, so here we're gonna have our final velocity minus initial velocity, which is 0 minus the 10. So you can have the 2750 multiplied by 0 minus 10. That's when we're gonna have 27,500. So this will equal to negative 27,500. Okay, so when we are here, let's divide by 2,500. 2,500, this will cancel, so change in time will equals to 11, because we have minus the 5,500. We have multiplied by 2,500, right? All right, so we have done all of this. Now we can calculate the distance. So for the distance, we are going to change in displacement equals to initial velocity plus final velocity over 2 times change in time. This is the formula we're going to use. So this equals to 10 plus 0 over 2 and then 11. So this will equals to 55 meters. This is the answer. Let's look at the memo. So here's question 4. You can pause it. This is the first option that I wanted to do, but it was just too much, and then I decided, because I have things, let me try to use this one, and it worked. Thank you very much for watching, guys. Until the next one.